And again, potential energy should be pretty easy because we had a whole unit on it. The only main type of potential energy that we're gonna be looking at, or our focus is gonna be on GPE, which is gravitational potential energy. All right, so potential energy is stored energy or energy of position. So this is the part of the definition that it can cause change. So it isn't actually doing anything at the moment. It has the potential to do something. And so this rock up here on the ledge has the potential to fall. We know that because of gravity. Okay, so it's the energy that something has because of usually its height above the reference. So these are the types we looked at last year. So we said that electrical energy is kinetic energy because the electrons are moving, but then it's also a form of potential energy because of how opposites will attract and like charges will repel. So it has the potential to cause some change based on what the charge is, like the overall charge of the object too. So electrical is both kinetic and potential energy, depending on how you're looking at it. But again, the main type that we're going to look at is the gravitational potential energy, and we abbreviate that GPE. Okay, this is the energy that's stored in an object as a result of its vertical position or its height. More massive objects are going to have a greater GPE, so you're probably a little bit more intimidated by a big boulder, like on a cliff, than you would be a little pebble. They're at the same height. I would rather be hit by the pebble than the boulder, personally. So more massive objects will have a greater GPE. Also, the higher something is, the more height it has, the more GPE it has. Because if you think about it, you're giving gravity more of an opportunity to act on it. So if I have something this high above my table or this high above my table, obviously gravity can act on it this whole way. That's giving it more opportunity and it has more potential to fall than it does when it's this height. Okay. And again, we talked about all this last year. So the GPE of the massive ball of a demolition wrecking machine is dependent on two variables. The mass of the actual ball, like kind of looks like a big giant bowling ball, and the height. So if I raise it up even higher and higher and higher and higher, it's going to provide more, or it has more potential to fall. If I make that ball bigger and bigger and bigger and bigger with more and more mass, it also has the potential to have more energy, and we could see that in the result of it crashing into the building that it's supposed to be demolishing. Okay. All right, so gravitational potential energy has an equation: mass, gravity, and height. We're going to use gravity as 10 meters per second squared again. And again, the units are going to be in joules because it's energy. All right. Mass times gravity times height. It's a pretty simple one. There is a triangle. Notice that it's a little bit different because there's 3 variables on the bottom, not just 2. So this line still means division. Okay? So if I'm solving for mass, I cover up mass, and it's going to be GPE over gravity times height. So mass equals GPE divided by gravity times height. Or if I'm solving for height, I cover it up, and height will equal GPE divided by mass times gravity. So there's just one extra multiplication because there's 3 variables involved, not just 2. And as we get to these practice problems, it's pretty easy. Looks a little funky in the triangle, but it's not bad. Okay, so let's just finish the notes here. Okay, so a plate of spaghetti has a mass of 1.3 kilograms and is sitting on a 1 meter high counter. How much GPE does the spaghetti have? Circle what you're solving for, and we're going to underline what we know. So Rory, what are we solving for? Okay, so we circle that. Give me a piece of information that is given. Ethan, give me something that's given here.
The counter is 1 meter.
Okay, So we have a height of 1 meter. We have a mass of 1.3 kilograms. That's underlined as well. And gravity is given. So I'm going to fill in my 1 meter high. So I've been given the mass. I've been given the height. By default, because we're here on Earth, it doesn't say we're on the moon or we're in some kind of simulation, so we know the gravity will be 10. So the equation is going to be mass times gravity times height. So all we have to do is multiply these three numbers. 1.3 times 10 times 1. And when we do that, it has a GPE of 13 joules. Good. This one's pretty simple. We started with the harder one, with the kinetic energy equation.